blocks of equal mass, okay, and I could put them. I could sort of hold this here, and I could say कि मैं इसको A से नीचे accelerate कर रहा हूँ. Obviously, these two blocks would also be accelerating downwards. But in this case, this A has got nothing to do with the change of length of the string on either side of the pulley. So if this constraint relation is arising from, this is what I wanted to prove. If this constraint relation is arising from the change of length of the string on either side of the pulley, then in this case, the two blocks, the disk and the block, they have an additional acceleration. And this additional acceleration has got nothing to do with the change of length of the string on either side of the moving pulley. So what we need to do, therefore, is we need to compensate for this acceleration. And the way to do it is to say that, look, let us look at it from the point of view of this moving pulley. And if I'm looking at it from the point of view of the moving, if I'm on that moving pulley, then definitely whatever acceleration I see for these two guys will be due to the change in the length of the string on both sides. Right? या समझने में मैंने बोला इसको मैं प्रूव कर दूंगा. I prove this subsequently. दिमाग में नहीं आ रहा. Okay. अच्छा, वाह, अच्छी बात. So this would mean that A minus A1 would be the acceleration of this point. This point, due to translation, would have an acceleration A2 minus A, and due to rotation, it would have an acceleration minus R. So I would get 2A is equal to A1 plus A2 minus R alpha. And we already know that A1 is equal to A2. So this will give me 2A is equal to 2A1 minus R. This would be the constraint relation. अब सॉल्व करने की कोशिश करते हैं. तो A की वैल्यू पहले लिखते हैं. टू टी बाई एम, 2 into 2t by m is equal to A1, 2A1. So this would be G minus T by m minus R alpha, which would again be equal to 2t by m. Right. So 4 plus 2 plus 2, that is 8t by m. 8t by m be equal to 2g. So t would be equal to mg by 4. Okay. Once again, we get t is equal to g.
सर आपने जो इक्वेशन लिखी है mg minus t equal to ma1, सर उसमें a1 में a का मतलब एक्सप्रेशन ऑलरेडी कंटेन्ड है.
A1 में क्या? हाँ, मतलब
Sir,
A1 जो है that is the acceleration with respect to the ground that I am saying.
हाँ सर बट फिर यहाँ पे वो A1 सेम कैसे चीज है, मतलब
कहाँ पे?
ये A1 और वो A1 अलग हो जाएगा ना, नीचे जो A1 लिखा है A माइनस A1 इक्वल टू A2 वो वाले इक्वेशन में।
नहीं 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 नहीं, देखो ये जो मैंने रेड में वेक्टर्स बनाए हैं A1 और A2, है ना,
हाँ
ये
सर,
विद रिस्पेक्ट टू द ग्राउंड,
हाँ सर,
ठीक है।
हाँ सर,
अब अगर मैं यहाँ पे बैठ जाऊं, यहाँ पे ये ऑब्जर्वर, and the observer is going down with an acceleration, then what does the observer, what does the relative observer do, what is the consequence of relative motion? आप कार में बैठे हो
पीछे हो
तो आप
जाएगा।
क्या
अच्छा,
बोलोगे? Everything
हाँ
has an acceleration a backwards, right?
हाँ सर,
सर
सर बट
हाँ
हम एक इक्वेशन के लिए अलग रेफरेंस फ्रेम और दूसरे के लिए अलग ले सकते हैं।
हाँ बिल्कुल।
सर ये ए अपवर्ड्स कौन कौन से में और होगा, मतलब कब कब लेना है हमें ए अपवर्ड
नहीं नहीं
डायरेक्शन?
नहीं 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 नहीं, आप don't think like that, don't think like that. If you look at this observer and this observer is moving with an acceleration a downward, that means that for this observer everything in the universe is moving with an a acceleration upward. आप after all जब गाड़ी में बैठ के 50 kilometers per hour road पे चलते हो, everything that you see outside the window is moving with a velocity of 50 kilometers per hour backwards, right? तो अब वहां पे अगर मान लीजिए आउटसाइड यूनिवर्स में एक ट्रेन है जो 30 किलोमीटर पर आवर से आगे जा रही है, that means it is going in your direction. You will say that look, according to me, everything in the universe has a velocity minus 50 meters, minus 50 kilometers per hour. And the train, in addition to this, has a velocity of 30 kilometers per hour. Therefore, the net velocity, therefore, the velocity observed of the train by you will be minus 20 kilometers per hour. Right? What has happened? You have subtracted, or you have said that, look, with respect to the ground, you have the velocity 30 kilometers per hour. That's okay. But I am assigning everything a velocity of minus 50 kilometers per hour. Therefore, I must assign you a velocity of minus 50 kilometers per hour. And since you already had a velocity of 30 kilometers per hour, the net velocity that you now have is minus 30 kilometers per hour. So in the same way, when I am at this location and I am as an observer moving down with acceleration a, then everything in my universe has an additional acceleration of a upwards. So this guy, with respect to the ground, already has an acceleration a1 downwards, but now it has an additional acceleration a upwards with respect to this guy. This guy already has an acceleration of a2 downwards, but with respect to this guy has an additional acceleration of a upwards. So with respect to this guy, then this object has an acceleration a minus a1 upper, and with respect to this guy, this acceleration has a this object has an acceleration a2 minus a niche. Okay? And because of rotation, of course, r alpha upper. A minus a1, which is the acceleration of this point upwards, according to this guy, must be equal to the acceleration of this point, must be equal to the acceleration of this point downwards. This point has an acceleration downward, which is a2 minus a due to translation, r alpha ऊपर की तरफ due to rotation, therefore minus r. ठीक है, आया समझ में?
यस सर,
ये मैं अगली क्लास में प्रूव कर दूंगा, अभी आई जस्ट वांट टू डू समथिंग एल्स बिकॉज़ टाइम खत्म होने वाला है। आई जस्ट वांट टू
सर
डू
इसमें सिग्मा टी आई ए आई इक्वल टू 0 का यूज
नहीं, इसमें सिग्मा टी आई ए आई का 0 इसलिए नहीं यूज कर सकते हैं क्योंकि सिग्मा टी आई ए आई का जो ओरिजिन है दैट इज बेस्ड ऑन द प्रीमाइस दैट द लेंथ ऑफ द स्ट्रिंग रिमेन्स कांस्टेंट. ओके, since the length of the string here does not remain constant because of the fact that the unwinding of the disk is unwinding to give you more string. Therefore, you cannot apply summation ti ai is equal to 0. ठीक है, कहीं गलती से कर मत देना.
ठीक है सर.
अगर मूविंग पुली आ गया तो फिलहाल आप ऐसे हैंडल करोगे. दिस आई विल प्रूफ, सेल्फ प्रूफ कैसे करें. फॉर द मोमेंट जल्दी से यू मस्ट मूव नाउ. सरफेस constraint. Very, very easy. If rigid body is moving without slipping on a surface, then the acceleration of point of contact and acceleration of surface in a direction parallel to surface, right? Very important. Must be same. हाँ, जरूरी नहीं है पार्थ, जरूरी नहीं है. So पार्थ is saying A is equal to R alpha आएगा, जरूरी नहीं. So the most important thing here, I think, is this. इसको हम अगर बिल्कुल देसी भाषा में बोले तो स्लिपिंग का मतलब होता है घिसना. What at least what I understand by the word घिस गया is that two surfaces have moved relative to each other. Then and only then this thing may happen. So what we are trying to say here is that, look, if this guy, cylinder, sphere, ring, whatever it is, if it is moving on this horizontal surface without slipping, then the velocity of this point, which is the point on the rigid body which is in contact with the surface, and the velocity or acceleration of this point, which is the again the point of the surface which is in contact with the rigid body, they must have the same velocity and the same acceleration in this direction. Okay? And it makes real sense, because if they don't have the same velocity or the same acceleration in this horizontal direction, वो जो ऊपर वाला rigid body है वो इस surface के ऊपर घिस जाए. It will slip. That is the definition of slipping. The way that you can think of, another way that you can think of slipping is that if you were to take a cylindrical object, something like your pen or something like a whiteboard marker, and if you were to color the surface of the pen black or blue or whatever color paint that you have, and if you were to roll that pen on your hand, on your forearm or hand or a surface, then after one rotation, okay, after one rotation, the length of the paint on the surface must exactly be equal to 2 pi. That means that there is a 1-to-1 correspondence between the surface of the pen and the surface of the table. What this means is that the two green points, they are in contact with the floor right now. But after a while, these two red points will be in contact. After a while, these two yellow points will be in contact. After some more time, these two black points will be in contact. After some more time, these 2 points will be in contact and so on. But whenever these points come in contact with each other, there is no relative motion of the rigid body with respect to the surface. The rigid body itself is not moving left and right. So, if you remember from the diagram that we drew when we were talking about rotation plus translation, we said that the acceleration of the lowest point due to translation, if the center of mass is moving with A, is A, and due to rotation, if the rotation is clockwise, alpha will be R alpha. And the net acceleration of this point will be equal to A minus R alpha. Now, if the rigid body is in contact with the stationary surface, that means that this point has got a velocity of A minus R alpha. This point has got a velocity of 0. They two must be equal. A must be equal to R alpha.
A minus R alpha acceleration है.
हाँ, इस point का lowest point का acceleration है ना A minus R alpha.
सर आप velocity.
हाँ, velocity acceleration कुछ भी ले लो, क्या फर्क पड़ता है? 2 बार डायग्राम बनाया था ना मैंने, velocity के लिए भी बनाया था और acceleration के लिए भी बनाया था.
Yes.
Velocity of any point on a rigid body or acceleration of any point on a rigid body is the vector sum of the velocity of that point on the rigid body if the rigid body was in pure translation and if the rigid body was in pure rotation. So if the rigid body was in pure translation, that means every point has the same velocity, which is equal to the center of mass velocity. So if the rigid body was in pure translation, the acceleration of the bottommost point would be A forward. And if the rigid body was in pure rotation clockwise, then the velocity or acceleration in this case of the bottommost point would be R alpha backwards. So the net acceleration when rotation and translation are both occurring simultaneously will be A minus R alpha. A उस तरफ, R alpha इस तरफ. If A is greater, जैसा मैंने assume कर लिया A minus R alpha उधर. If R alpha is greater than R alpha minus A इधर. But in this case, we apply the constraint and we say that look, the net acceleration of this point of contact must be the same as the acceleration of the or velocity of the point of contact of the surface. In this case, the surface is stationary. Therefore, the point of contact must also have 0 acceleration. Therefore, A is equal to R alpha. But this does not mean, remember, that this point has 0 acceleration. This is very important. I told you this is very important. This is acceleration in a particular direction is 0. This point on the disk or circle or sphere does have an acceleration and it is vertically upwards and it is called the centripetal acceleration. वो तो है ही है इसके पास, right? Okay. So I want to discuss a couple of questions on this. So let's say that somebody tells me that they are applying a force F on the cylinder. Now, I will tell you later on how to find the direction. In fact, next class we'll discuss this only. How to find the direction of friction between the surface and the rigid body. It's actually very easy, not difficult at all. You can assume it to be anywhere. You'll still get the correct answer, but it always is good to know. So in this case, I want to find the acceleration of disk if there is no slipping. And the radius is given as r, the mass is given as. What kind of motion is it going to execute? Well, it is going to execute translation and rotation. So before I analyze translation and rotation separately, I must draw the free body diagram. Since I don't want to, and obviously you also don't want to draw the two free body diagrams, so we'll draw just one and make do with that. So यहाँ पे force F लग रहा है, mg लग रहा है, n लग रहा है, और friction लग रहा है. Yeah. Now please notice that friction की value मैंने small f ली हुई है, because slipping नहीं हो रही है. इसका मतलब कि मेरे पास गारंटी है that the friction has not reached its maximum. So now I will write down for translation of the object. For translation of the object, we will get F plus F is equal to ma. And for rotation of the object, we'll get Fr minus Fr is equal to 1. Okay. Now you may say, and you should say, कि ये friction आगे क्या कर रहा है? पीछे क्यों नहीं है? But I hope that by now I have convinced you that friction is least bothered about your intuitions, and it will work as it works, right? And I will show you in the next class how the friction is.
सर लेकिन फ्रिक्शन तो अपोजिट डायरेक्शन में लगता है ना फोर्स के.
देखा भाई, मैंने बोला ना, आपका जो भी इंट्यूशन है, मैंने उसको थोड़ा सा मैंने चेंज करने की कोशिश करी थी, लेकिन वो चेंज करना मेरे को लगता है इम्पॉसिबल. अगर एक ऑब्जेक्ट सर्कुलर मोशन में है तो फ्रिक्शन किधर होएगा? बना याद है ना, परपेंडिकुलर टू वेलोसिटी.
यस सर.
और फ्रिक्शन अगर नॉन यूनिफॉर्म सर्कुलर मोशन हो रहा है ऑब्जेक्ट का, तब तो फिर कहीं भी हो सकता है. so on. I'll tell you why. But you may absolutely say, no, I don't want to do this, and I will take भैया फ्रिक्शन तो फोर्स के ऑपोजिट होता है, मैं तो उल्टा ही लेके चलो. ठीक है, आप कर सकते हो. That case you write the equations F minus F is equal to ma, and you will write Fr plus Fr is equal to I alpha. In both cases, you are going to get the same answer. Okay? That is the wonderful thing about this. So the acceleration due to forces, if I can say that it is A, which is what I have to find. So acceleration of center of mass is A, then acceleration due to translation will be A. And since the torque on it is clockwise, therefore the acceleration due to rotation is R alpha in the backward direction. Therefore, the net acceleration of this point is A minus R alpha, but this acceleration should be equal to the acceleration of the point of contact of the surface, which is equal to 0. Therefore, A minus R alpha should be 0, and A is equal to R alpha. If A is equal to R alpha, right? If A is equal to R alpha, then you will get here F plus F. plus F is equal to MA, and you get F minus F is equal to MA by 2. मैंने MR square रख दिया और R सब cancel हो गया. So when I add this, I get 2F is equal to 3MA by 2. And this tells me that A is equal to 4F by 3. Very, very unexpected result, because मैंने एक बॉडी को F4 से खींचा और उसका एक्सेलरेशन में नहीं है, कुछ अजीब ही सा है, जो है वो है. इस केस में ये जो अगर आपने फ्रिक्शन उल्टा ले लिया, इस केस में भी यू विल गेट F माइनस F इज इक्वल टू MA, F प्लस F. अल्फा कैसे निकाला? हाँ मैं बताऊँ. F plus F is equal to MA by 2. Add them up, and again you get A is equal to 4F by 3. So the direction of friction does not matter. However, it is better to use the correct. It is better to use the correct direction of friction. Right? It will be helpful later on. हाँ. So the question is कि अल्फा कैसे निकाला? मैंने इसका रोटेशनल एलवीडी बनाया हुआ है और मैंने यहाँ पे टॉर्क देखा. F कैपिटल F की वजह से इट इज क्लॉकवाइज, स्मॉल f की वजह से इट इज एंटी क्लॉकवाइज, एंड आई नो दैट इफ इट इज मूविंग फॉरवर्ड देन इट मस्ट बी गोइंग क्लॉकवाइज. सो क्लॉकवाइज टॉर्क माइनस एंटी क्लॉकवाइज टॉर्क इज इक्वल टू I. क्या? चलो, so quickly before we go, very quickly please.
सर फ्रिक्शन है कि
हाँ, नो स्लिपिंग है तो फ्रिक्शन तो होना. नहीं शौनक, M और M पे डिपेंड करेगा ना. हाँ डिफरेंट मासेस है ना. नहीं तो थोड़ी सी गलती है, बहुत ही सिली मिस्टेक है, तो करेक्ट करो. हाँ शो. नहीं नहीं गलत है शोना यार. नहीं नहीं. देखो भाई सब लोग. So we talk about यहाँ पे कोई आइडियल पुली है, ये मूविंग नहीं है, तो कोई लोचा नहीं है. We can just apply whatever we have done, the easy वाला. So for block mg minus t is equal to ma1. So I'm saying that this is going down with a1, and I'm saying that let the tension here also be T, and let the acceleration of this be T. So for the translation of the cylinder, we get T plus F is equal to ma. Tr minus Fr is equal to mr square by 2 into L. Right? Constraints. My part. Look at the constraint. Very, very important. Acceleration of this point due to translation is a2. Since it is having alpha angular acceleration, it must also be r alpha. Acceleration of this point is a2. Because of rotation, the acceleration of this point is r alpha. So the net acceleration of this point is a2 plus r alpha. The net acceleration of this point is a2 minus r alpha. First, the string constraint gives me a2 plus r alpha is equal to a1, and the surface constraint gives me a2 minus r alpha is equal to 0. You must be absolutely clear about the constraints. So we get A1 is equal to 2RF. Now let's write down the equations. P plus F is equal to MA.
सर वो
Mine.
A2 होगा ना
हाँ
T plus F equal to MA2
MA.
MA A2
हाँ. So T minus F is equal to M by 2 into हमको A2 निकालना है राइट तो मेरे को इसको
सर
A2 के टर्म
A2 A1 by 2 होगा
A1 is equal to 2. So this will be equal to A2. यहाँ तो A2 ही आएगा यहाँ पे. And I will write down mg minus T is equal to MA1, which is 2M. I'll multiply this by 2, so I get 2, 2, and 4 here. Add them all up. 2T here. F here. So I'll get 2mg is equal to A2 common ले लेना 4m plus m plus m. Therefore, A2, which is what we have to find, equal to 4mg upon
4M
8m.
small m 8 small m plus 3 capital M
Okay. So I'll stop here, and next class I will continue from this. Or I'll try to in the next class also. I'll try to, if I can think, I'll try to prove that ये जो constraint string constraint आते हैं, this is because of the change in length, because of the length of the string. ठीक है? चलो, so I will go. कोई doubt किसी को? का? चलो.